Your turn signal quits, and suddenly the car feels older than it is. You're sitting at an intersection, you flick the stalk and nothing happens. Or it blinks like a machine gun. Or the dash arrow lights up but the outside lamps stay dark. If you search for turn signals not working on Toyota Corolla Cross, you're probably hoping it's a simple fuse or a bulb. And sometimes it is. The problem is that on a modern Corolla Cross, the turn signals aren't just a dumb circuit with a classic flasher relay you swap in 5 minutes. They're often controlled by a body module that decides when and how to blink, and that changes what simple looks like. Here's the good news, you can still diagnose this without randomly buying parts. The trick is to stop thinking what part failed, and start thinking, what exactly is the car doing? Because one tiny detail, like whether the hazards work, can tell you if you're chasing a lamp problem, a power problem, a switch input problem, or a control module decision. Start with the fastest reality check, what's the exact failure mode? If one side doesn't work but the other side does, that's a completely different story than both sides being dead. If the hazards work but the turn signals don't, that points you away from the lamps themselves and toward the stalk input or the way the body module is interpreting it. If the dash indicator is fast, that usually means the car thinks a bulb or LED load is missing on that side, even if you can't immediately see it. If the dash indicator doesn't light at all, that can be a power supply issue, a switch input issue, or a module issue. So before you touch anything, do a quick observation pass. Engine off, ignition on. Try left signal, right signal, and hazards. Watch the dash arrows. Walk around the car and confirm what the front and rear lamps are doing. If you have mirror indicators, check those too. And if you have a friend, have them operate the stalk while you watch the lights, because intermittent faults love to disappear when you're alone. Now, a safety note that matters. You can do a lot of checks without going anywhere near airbags. Avoid pulling steering column covers or poking around yellow connectors. If you're not sure what you're touching, don't touch it. Most of what you need is accessible at the lamps, the fuse boxes, and with basic electrical checks. Let's talk about the easy wins first, because they solve a surprising number of cases. The first easy win is the lamp itself and its connector. On many Corolla Cross trims, the turn signals are part of an LED assembly rather than a replaceable bulb. That changes the failure pattern. A bulb usually fails cleanly, it's out, you replace it, done. An LED assembly can fail intermittently, or it can fail in a way that confuses the car's load detection. And even if the LED unit is fine, the connector can be the real villain. So check the obvious physical stuff. Look for moisture inside the lens, fogging that never clears, or water trails. Look at the connector area for signs of water intrusion, greenish corrosion, white crust, or a connector that doesn't feel fully seated. If you can access the connector without major disassembly, unplug it and inspect. You're looking for bent pins, push-back pins, corrosion, or a loose locking tab that lets the plug back out over bumps. If the problem is intermittent, do a gentle wiggle test. With the signal on, lightly wiggle the harness near the lamp connector. If it flickers, you've learned something valuable, the circuit is capable of working, but the connection is unstable. That's not a fuse. That's not a module. That's a connector, a pin fit issue, or a broken wire near the plug. If only one corner is out, and you can swap a bulb from side to side, that's a classic test. If the dead side follows the bulb, you found it. If it stays on the same side, you're looking at wiring, connector, or the lamp assembly itself. With LED assemblies you often can swap a bulb, but you can still compare behavior side to side. If the left rear is dead and the right rear is bright and crisp, that contrast helps you spot a dim or partially working unit. Next easy win, fuses. People either ignore fuses or they go full chaos mode and start pulling every fuse they can find. Don't do that. You want targeted checks, and you want to check them correctly. A fuse can look fine and still be blown in a way that's hard to see. The best quick method is a continuity check with a multimeter, or using a test light on the fuse's test points if your fuses have them. Your owner's manual or the fuse box cover diagram will help you identify which fuses relate to turn signals, hazards, body ECU, or exterior lighting. Depending on configuration, the hazards and turn signals may not share the exact same fuse path, which is why hazards work doesn't automatically mean fuses are fine. If you find a blown fuse, don't stop at replacing it. A fuse usually blows because something pulled too much current or shorted to ground. If you replace it and it pops again immediately, that's your sign to stop feeding it fuses and start looking for the short. Common triggers include water in a lamp connector, damaged wiring near a hinge area, or aftermarket wiring like trailer harnesses and alarm/remote start taps. That brings us to another easy win that people underestimate: battery voltage and charging health. Turn signals are simple, but the control logic behind them is not. A weak battery or unstable voltage can cause body electronics to behave strangely. You might see intermittent blinking, weird dash behavior, or functions that work only with the engine running. If you have a multimeter, check battery voltage with the car off and then with the engine running. You're not hunting for a specific magic number here, you're looking for obviously low or obviously unstable. If the battery is struggling, fix that first. It's not glamorous, but it prevents you from blaming the body module for what is really a power supply problem. Also, do the simplest reset that costs nothing: ignition cycle. Turn the car fully off, open and close the driver door, wait a moment, then restart and recheck. If the issue disappears temporarily, that doesn't mean it's fixed. It means the system can recover, which often points to an intermittent connection, moisture, or a module seeing a fault and then clearing it until it happens again. Now let's move from easy wins to the part that makes this topic trickier than it seems: how the Corolla Cross actually decides to blink. On many newer vehicles, the stalk isn't directly powering the lamps. The stalk is more like a request. You move it left, and a signal goes to the body control system. The body module then commands the left lamps to blink, monitors the circuit, and reports to the dash indicator. That's why old school advice like, replace the flasher relay, often goes nowhere. There may not be a traditional flasher relay you can swap, or the relay function is integrated into a module. This is where one observation becomes the single most useful clue: do the hazards work normally? If hazards work and both left and right lamps blink properly in hazard mode, that tells you the lamps, their grounds, and much of the output side wiring are probably okay. It also suggests the body module can drive the lamps. So if hazards work but the left/right turn signals don't respond to the stalk, you're now looking at the input side, the multifunction switch, its wiring, or the module's interpretation of that input. On the other hand, if hazards do not work either, and both sides are dead, you're more likely dealing with a shared power supply issue, a main fuse, a module power/ground issue, or a broader body electronics fault. Now consider the fast blink, often called hyperflash. People associate hyperflash with old cars and burned out bulbs. But even with LEDs, the car still tries to detect whether the circuit is healthy. If it thinks the load is missing or the current draw is wrong, it may speed up the dash indicator to warn you. That can happen if an LED assembly is failing, if there's corrosion adding resistance, if a connector pin is loose, or if someone installed aftermarket LED bulbs where the system expected a different load. Aftermarket LEDs are a huge source of confusion. If your Corolla Cross has been modified with LED bulbs, resistors, or a trailer wiring adapter, you've introduced variables that can mimic a failure. A resistor that's poorly connected can heat up and fail intermittently. A cheap LED bulb can work for a week and then start flickering. Trailer wiring can backfeed voltage into circuits in ways the body module doesn't like. If any of that applies, the cleanest diagnostic move is to return the circuit to stock temporarily and see if the symptom changes. Now, how do you test without guessing? You need one basic tool, a multimeter or a simple test light. And you need one basic idea: separate the problem into command versus power. If a lamp is not blinking, you want to know whether the lamp is receiving a pulsing voltage when the signal is commanded. If it is receiving a pulsing voltage but not lighting, the lamp assembly or ground is suspect. If it is not receiving voltage at all, then the issue is upstream, fuse, wiring, module output, or the module never got the command. Here's a practical approach that avoids deep disassembly. Start at the lamp connector on the side that's failing. With the turn signal commanded on that side, probe for voltage on the turn signal feed pin relative to a known good ground. If you don't have wiring diagrams, you can still do comparative testing: check the working side connector and see which pin shows pulsing voltage during signaling, then check the same pin position on the dead side. You're not trying to become an electrical engineer, you're using the working side as your map. If the working side shows a nice pulsing voltage and the dead side shows nothing, you've narrowed it to wiring between the module and that lamp, a connector issue, or a module output issue for that channel. If the dead side shows pulsing voltage similar to the working side, but the lamp doesn't light, suspect the lamp assembly or its ground. Grounds can fail in sneaky ways. A ground that's partially corroded can pass a little current but not enough, causing dim light, flicker, or weird behavior where the lamp tries to find ground through another filament or circuit. With LEDs, that can look like ghosting or erratic blinking. A quick ground sanity check is to measure voltage drop. If you're not comfortable with that, here's the simple version: connect your test light or meter ground to the battery negative terminal, not to the car body near the lamp. Then test the lamp feed. If it suddenly behaves differently compared to when you used a local ground, your local ground may be the problem. Now, what if both sides are dead, or the dash indicator doesn't even acknowledge your stock input? This is where a scan tool can save hours. Not a fancy dealer tool necessarily, but a scanner that can read body codes and live data, not just engine codes. Many basic OBD readers only talk to the engine computer. You need one that can access body systems. If you have that capability, you can look for stored codes related to turn signal circuits, lighting outputs, or switch inputs. More importantly, you can sometimes view live data that shows whether the body module sees the turn signal switch being moved left or right. That live data is the closest thing to a truth serum in this situation. If the module sees left turn request on when you move the stalk, then the switch and its wiring are probably fine, and the problem is on the output side. If the module never sees the request change, then the stalk input path is suspect. And this is exactly why hazards versus turn signals matters. Hazards often use a different input path than the turn signal stalk. So you can have perfectly working hazard blinking and still have a dead turn signal request because the stalk contacts are worn, contaminated, or the internal mechanism is failing. If you don't have a scan tool, you can still infer a lot. If hazards work, but the dash indicator never responds to left or right, that's a strong hint the car isn't receiving the stock command. If the dash indicator responds but the exterior lamps don't, that suggests the command is being recognized but the output isn't happening, or the module is shutting down the output because it detects a fault. Intermittent behavior deserves its own moment, because it's the most frustrating version of this problem. Signals that work when the car is cold and fail when it's hot, or work after a bump, or fail only in rain, are almost always connection related. Moisture in a connector, a pin that expands with heat, a wire broken inside insulation near a flex point, or a ground point that's barely hanging on. If rain correlates with failure, focus on lamp housings and connectors first. If bumps correlate, focus on harness routing and connector seating. If temperature correlates, suspect a component that's marginal, like an LED driver inside a lamp assembly or a switch contact that changes resistance with heat. Now, a word about the multifunction switch, the stock itself. People either fear it because it's near the steering wheel, or they blame it immediately. The truth is in the middle. The stock can fail, but you don't want to tear into steering column components casually. If your diagnosis points strongly to the stock input not being recognized, that's the moment to stop and decide whether you're comfortable going further. A professional can confirm switch input with scan data and proper procedures without risking airbag-related issues. Also, don't overlook the simplest human factor, the hazard switch itself and the way the system behaves when it's partially engaged or sticky. If the hazard button feels odd, doesn't click cleanly, or seems to stick, it can create confusing symptoms. That's not the most common cause, but it's easy to check. Let's connect all of this into a clean decision path, because that's what you actually need when you're standing in the driveway. If only one side fails and the dash indicator is fast, think the car thinks a lamp is out. Check that side's front, rear, and mirror indicator if equipped. Check for moisture and connector corrosion. If it's a bulb type setup, swap the bulb. If it's LED assembly, inspect the connector and harness, and compare voltage pulses to the working side. If one side fails and the dash indicator behaves normally but the lamp is dark, suspect the physical connection or the lamp assembly itself. Test for pulsing voltage at the connector. If voltage is present, the lamp or ground is the likely culprit. If voltage is absent, trace upstream, fuse, harness, module output. If both sides fail but hazards work, suspect the stock input path or the module's interpretation of it. This is where a scan tool that can read body live data is extremely helpful. Without it, you can still make a reasonable call. Hazards prove the outputs and lamps can blink, so the missing piece is the turn request. If both sides fail and hazards also fail, start with shared power, fuses, battery voltage, and any recent electrical work. If you recently installed anything electrical, especially trailer wiring or aftermarket lighting, temporarily disconnect it and retest. If power and fuses are good and nothing works, you're likely beyond simple DIY and into module power/ground, network communication, or internal module faults. And if the signals work sometimes and not others, stop thinking replace parts and start thinking recreate the failure. Wiggle the harness near the lamp. Check after rain. Check after a car wash. Check when the trunk or hatch is open and closed. Intermittent faults are usually mechanical or environmental. Now, let's talk about what not to do, because the wrong move can turn a small problem into an expensive one. Don't shotgun relays. On many modern cars, you can waste hours swapping relays that have nothing to do with the function, and you can even create new issues by not seating them properly. Don't keep replacing fuses if they blow repeatedly. That's how you melt wiring. Don't probe random wires near the steering column. And don't assume that because the dash arrow blinks, the exterior lamps must be getting power. The dash indicator is a message, not a direct measurement. If you reach the point where you suspect a module or you need to confirm switch input, going to a shop isn't giving up. It's choosing the right tool for the job. The best way to use a shop visit is to arrive with clear observations. Tell them whether hazards work, whether one side or both sides fail, whether the dash indicator is fast or dead, and whether the issue is intermittent with rain or bumps. That information saves diagnostic time and reduces the chance they'll start guessing too. And if you're still in the, I just need my signals back today, mindset, here's the practical priority, make the car safe and legal to drive. If you can't restore turn signals quickly, don't rely on hoping other drivers will read your mind. Use hand signals only if it's legal and safe where you are, and consider postponing driving until you can fix it properly. Electrical problems have a way of escalating when ignored, especially if moisture is involved. So when you hear, turn signals not working on Toyota Corolla Cross, the real story is not one part. It's a system that can fail at the lamp, the connector, the power supply, the switch input, or the body control logic. The single check that often splits the problem in half is hazards versus turn signals. Hazards working pushes you toward input and control. Hazards failing pushes you toward power and shared faults. From there, a simple voltage test at the lamp connector, compared side to side, tells you whether you're dealing with a dead output or a dead lamp. If you take only one mindset from this, don't guess. Observe, compare left to right, and test for power where the light actually connects. That's how you fix the problem without turning your Corolla Cross into a parts cannon experiment. And if you do end up needing professional diagnosis, you'll walk in with a clear story instead of a vague complaint, which is often the difference between a quick fix and a long, expensive chase.